Hey guys, Travis Gillespie. How can you determine if a particular function is linear? Suppose you're given an algebraic expression of a function. How do you know if it's linear? And let's scroll over here and get some fresh screen. So here's an algebraic representation of a function. Let's determine if this is actually linear. Well, one way to determine if a function is linear is to express it in what is called standard form. Well, standard form of a linear equation, really all it's saying is a constant times x plus another constant times y equals a constant. And what you have here are real numbers, and, well, both a and b, they cannot both be 0. Well, if you can take any function and express it this way, well, then you know, in fact, it must be a linear function. Or in other words, it must be a line. Because it satisfies the standard form. Heck, bottom line, if you don't see typically any x squareds or y squareds or denominators, anything like that, and some constants, you're probably in good shape to having a linear function. Well, let's just keep taking a look here. And let's confirm that this intuition is right by expressing this function in standard form. Well, let's see if I can do this. Well, in fact, I'm just going to rewrite it because I'm going to be moving some things around here. So I'm going to say, hey, y equals x plus 2. And, well, if I subtract x from both sides, like so, I end up with, well, I'm going to change colors and actually change my pen size here. Well, I end up with, well, negative x on the left side. Well, that would be, well, negative 1 x. Say x in green here. Plus, well, 1 times y, and that's going to actually equal 2. Well, you can actually notice that written this way, I can actually think of this as the a constant, and this as the b constant, and actually this is the c constant. And since I can do this, well, I've written this in this standard form here, so therefore, well, I know that since I can do this, I can represent this as a linear function. And notice that the a, the b, and the c actually have to be numbers. They can't be variables. They can't be letters here. They have to be real numbers. Well, now that it's been determined that this is a linear function, let's actually see what we can do. Take it for a ride here. So I'm going to create a little bit of a value table here and just make up some numbers. And, well, using the equation as before, well, I find that when I substitute -1 in for x, I find y is 1. When I substitute 0 in for x, I find that y is 2. And when I find or substitute 1 in for x, I find that y is 3. Well, Well, the bottom line, I see that when I graph this linear function, well, it has a straight line. Therefore, it is a linear function. Cool.